Welcome to chapter 4. This chapter is about libraries and modules. For the very first question, we're asked to write a function called conversion and then provide methods along with some documentation. Here's how you get started. Start with a multi-line string on top of the file. This is going to provide a module level documentation. Following that, have your constants. Finally, have your methods. Each one should have its own docstring. This is called as a docstring, and that's about it. Let's see this in action. Go to this folder and then start your Python interpreter. Import this module called conversion. When you type help conversion, here's the output. You see the name, you see the description, the functions, and the data. Notice that this text corresponds to each section of text that appears in the documentation corresponds to the docstring for that particular section. The docstrings are associated at two levels. One is for the function, the other one is for the module level. Hit the Q key to return back to the prompt. Here is how you invoke a function. So if you wanted to invoke conversion dot Celsius to Fahrenheit of say 5, it's going to be 41.0. Let's now turn our attention to the first problem in part 2 of chapter 4. We're asked to compute the area of an equilateral triangle by accepting the measure of the side from user. So as always, we use the input function to get the string input of the side, convert it to a float, and then assign it to a side. A simple assertion to make sure that triangle side should be non-negative. Then we make use of the Python built-in module called math. Remember that math is just a file, a Python file that's going to contain constants and functions. We make use of the square root function inside the math module to calculate the square root of 3 divided by 4 and then multiplied by side square. Finally, print the desired result. Here's a demo. This is the area of an equilateral triangle. A few things to bear in mind. It's a good practice to import the module right at the top of a file. That's not always necessary though. All you have to do is import this math module before its first usage, because the symbol has to be known to the Python interpreter. You can place it anywhere here. And one more thing is math.square root, that's the same as the number power 0.5. So here we are. We've replaced the side power 2 with math.pow of side comma 2. This calculates the square, and if you run it again, we'll get the same result. Here's the second problem. We're asked to take as inputs the number of sides of a regular polygon and the length from center to a corner. So these are the two input variables, and we're supposed to print the area of the polygon. If you look at the formula that's given in the textbook, it's half times n times sine of 360 degree divided by n. The 360 divided by n is inside the sine, and outside the sine again we have s square, where s is the length from center to corner and n is the number of sides. So after getting these two inputs, we now program this formula. One thing to bear in mind is sine takes in radians and not degrees as the input parameter. So we need to convert 360 divided by number of sides to radians. That's the only thing to keep in mind. Here's a demo. 4 sides, center to corner say 8. This is the area. And to show what's there in the example, the number of sides is 4, the length is 5, area is 50. On a side note, you can either import just math and then type math.sine, math.radians and so on, or from the module you can import the functions directly and call them like regular functions. Both are okay. Let's now turn our attention to the fourth problem. We're asked to pick a random integer between 100 and 1000, endpoints included. We import the random module here. After that, we make use of the randint function that takes in two parameters, a start and an end, both endpoints included. It will generate a random number in the range. And then we use an f string to print the outcome. Here's the demo. Keep executing it a bunch of times and you'll notice random numbers being spit out. There is only one question in part 3. It's question 2, and that's what we're going to talk about now. Part 3 in chapter 4 asks us to create a package structure. The root level should be a package called mailsys. Inside that, we should have another package called archive. There should be a module called deliver inside mailsys and a file called another module called old mail inside archive. Each folder to be treated as a package should contain the init__ .py. It can be empty, but the file just needs to be present. Let's look at the functionalities that we've been asked to implement. So inside the deliver file, we provide a docstring and then wanted us to have functions for sending mail, getting mail, draft, outbox, and inbox. They said you can have any functionality you want inside, so I'm just adding a bunch of print statements to show that those methods have been invoked. Similar to deliver, there is also this old mail module. This contains two methods that they've asked us to have. The readme here shows you how to run these. So go inside the 4_3 folder, invoke Python, and then write in the interpreter, start typing these sentences, and you'll see the corresponding outputs. Those lines that begin with triple greater than symbol and then a space are where you have to type the inputs, and you'll see the corresponding output here.